Hello again. Today we are going to talk about Chapter 2, Descriptive Statistic. Descriptive Statistic. Now, Chapter 2.1 is very short, nice chapter, and we are going to mainly talk about stem and leaf graph, right? Stem and leaf plot, stem and leaf graph. Now, sometimes they call this stem and leaf plot. Sometimes they say this is some stem and leaf graph, right? So now we are moving on to chapter 2, which is the descriptive statistic. Remember in our first chapter, chapter 1, we talked about there are two main different branches in statistic. One was descriptive statistic. Another one was inferential statistic. So what's the difference? Well, inferential statistic, you make decision at the end. You make educated guess. You make prediction. That's inferential statistic. But descriptive statistic, as the name suggests, you describe what's out there. You don't make decision. You don't make suggestion. You just simply describe what's out there, right? Okay. One of the easiest way to describe a data is using stem and leaf graph. Stem and leaf graph. I mean, stem and leaf plot, stem and leaf graph. This is just to organize data in a certain way so that we can easily see what's going on in that data set, right? So let me actually give you an example. Now let's say you have this number 23. This is one of the data. Now there is then you gotta divide this number into two parts, namely right here. So this number 2 is going to be the stem part, and this number 3 is going to be the leaf part, right? If you have a 2-digit number like that, and that's how you divide the stem part and the leaf part. Now, for example, if you have 3-digit number like that, then we cut it right there, and this 43 is going to be the stem part, and this 2 is going to be the leaf part. Let's say you have 4-digit number like this, then again you cut it right there. This is going to be the stem, and this is going to be the leaf. So what do they have in common? It looks like the last 1 digit is going to be the leaf part. Any previous number is going to be the stem part. Now let's say you have this decimal number, 9.3. Again, you cut it right here. That's going to be the leaf. That's going to be the stem. Let's say you have 97.5. Again, then you cut it right here. That's going to be the stem. This is going to be the leaf, just like that. But in many of the real example, you are mainly going to deal with 2-digit number, right? Almost all the time. 3, 4-digit number, they don't really use stem and leaf plot. But mainly 2-digit number that you are going to use this stem and leaf graph. Well, how do you actually make that graph? Well, they say draw a vertical line that divide the stem part and leaf part, and you reorganize it. I mean, let's take a look at this example. Let's say this is one of those exam results. Like, let's say there's a pre-calculus course, then these numbers, right? All these numbers represent those exam results. Now, we talked about this, right? One possible way, I guess, to organize this is using what we learned in the previous chapter, which is the frequency table. But this time we are trying to build what's called the stem and leaf graph. Now, for example, this first number, 33, right? We're going to divide into two parts, the stem part and the leaf part. This number 2, 42. This is going to be the stem part. This is going to be the leaf part. So you check out all the stem numbers, and you know this data is already in order, which is nice. Sometimes they're not in order, and then you have to order them first, or you build a stem and leaf and then order it, you know, whichever way that you prefer. Let's say you check out all those stem numbers. It's ranging from 3 to all the way to 10. That's how you have this stem number. So you have this. Sometimes they do have this vertical line. Sometimes they just have space like this. Now, stem number ranging from 3 to 10. So now that you set up your stem part, now you are checking your leaf part. First number, 3. That's how we get this 3, right? The second number, 42. So 42 right there. The third number, 49. 49, right? So you just, if you have whatever number, let's say 72, you know that this is going to be the stem, this one right there, and leaf is going to be 2, and that's this number right there, right? This number 73, again, same stem. You don't repeat the stem. You just write once. Leaf part, 3, then you got it right there. So, you know, once you go through all those data points, then you have your stem and leaf plot just like this, right? So, you know, check out these original data sets compared to this stem and leaf. You can definitely see why this is one of the popular way to present the data, because you can see the general trend, right? You can see right away a lot of 60-something, a lot of 90-something, 70, 80-something is still there, but there's also, you know, student who got 33, student who has no idea what's going on, and student also got 100, student already know everything before you take this class, you know, something like that. So not only you see each individual detailed data, but you can see the general trend. That's why this stem and leaf plot is very popular and also very powerful, right? Okay. So let's say, let's talk about this example. This data describe the distance from home to your local supermarket, right? They say it's in kilometer, whatever, right? So this data is also in order, right? From 1.1, I guess biggest number is 12.3, right? Whoever this person is, they live far away from local supermarket, I guess, right? So stem part, let's say if you have 1.1, cut it right there. This is going to be stem, right? This is going to be the leaf. For example, 4.5, cut it right here, stem and leaf. So let me give a little bit of time. Well, at least figure out what stem is going to be and how do you write those stems, right? Why don't you just do it right now, right? At least try to figure out what the stem is going to be. I can, right? Let me give you just a little bit of time. Right, the stem part is ranging from 1 through 12, right? So these are the stem number, right? 1 through 12. Notice that they actually wrote all this number even though they don't have any leaf part here, right? Now, let's say this 1.1, stem 1, leaf 1. This number 1.5, stem 1, leaf 5, right? Just like that. Let's say this number 6.5, stem 6, leaf 5. This number 6.7, stem 6, leaf 7, just like that. Now, you can see that it's concentrated in here, meaning, especially these two, right? You can see the highest frequency right there, a lot of numbers here. So, it's safe to say most people live anywhere between 3 to 4 miles away from their local supermarket, right? Because you can see this is highest concentration. And this number 12.3, you don't really have any number in here, but you have this relatively big number compared to the others. And what do you call this number that stands out because they are very different from others? It's called outlier. This may be an outlier. And later on, we are going to learn a technique to figure out this outlier. I'm going to learn a technique to figure out this outlier. Okay. That's it for this chapter. Relatively nice and short. Okay.